National Electrical Code, or NEC, dictates the permissible number of conductors within a specific size of conduit to ensure safe and efficient electrical installations. This is known as conduit fill. For a 3/4-inch electrical metallic tubing, or EMT conduit, the maximum number of number 10 American wire gauge, or AUG, stranded conductors permitted is 3. This limitation is in place to prevent overheating of the conductors due to insufficient heat dissipation. Overfilling a conduit can lead to several problems. Firstly, it restricts the ability of the wires to dissipate heat. Electrical current flowing through a conductor generates heat due to the conductor's resistance. If the heat cannot escape, the temperature of the wires will rise. Secondly, excessive heat can degrade the insulation of the wires, leading to short circuits, ground faults, and potentially electrical fires. Thirdly, physical damage to the conductors can occur during installation when pulling them into an overfilled conduit. The insulation can be scraped or torn, compromising its integrity and increasing the risk of electrical hazards. The NEC specifies conduit fill requirements in Chapter 9 and related tables. These tables provide the maximum allowable percentage of the conduit's cross-sectional area that can be occupied by conductors. The percentage fill allowed depends on the number of conductors within the conduit. For example, when there are 2 or fewer conductors, the maximum fill percentage is 40%. When there are more than 2 conductors, the maximum fill percentage is 40%. The NEC provides tables that list the dimensions and cross-sectional areas of various types of conductors, including number 10 AWG stranded wire. It also provides tables that list the internal dimensions and cross-sectional areas of different sizes of conduit, including 3/4-inch EMT. To determine the maximum number of number 10 AWG stranded wires that can be installed in a 3/4-inch EMT conduit, you need to consult these tables. A table for conductor properties will show the outside diameter of a number 10 AWG stranded wire, including its insulation. The table for conduit properties will show the inside diameter and cross-sectional area of a 3/4-inch EMT conduit. Using these values, you can calculate the cross-sectional area of each number 10 AWG stranded wire and compare it to the available cross-sectional area of the 3/4-inch EMT conduit. Keep in mind the fill percentage limitations based on the number of conductors. In the case of number 10 AWG stranded wires in 3/4-inch EMT conduit, the NEC allows a maximum of 3 conductors. This is because the combined cross-sectional area for number 10 AWG stranded wires would exceed the allowable fill percentage of the 3/4-inch EMT conduit. It's important to note that the NEC is updated regularly, so it's essential to refer to the latest edition to ensure compliance. Local jurisdictions may also have their own electrical codes and regulations that may be more restrictive than the NEC. Always consult with a qualified electrical inspector or engineer to ensure that your electrical installations comply with all applicable codes and regulations. There are some factors that can affect conduit fill calculations. Firstly, different types of conductors have different dimensions. For example, THHN wire, which has a thinner insulation than THW wire, will have a smaller overall diameter. This means that you may be able to fit more THHN wires in a conduit than THW wires. Secondly, different types of conduit have different internal dimensions. For example, rigid metal conduit, or RMC, has a larger inside diameter than EMT conduit of the same trade size. This means that you may be able to fit more wires in RMC than in EMT. Thirdly, the presence of fittings such as couplings and connectors can reduce the available space inside the conduit. Therefore, it's important to take these factors into account when calculating conduit fill. To accurately determine the maximum number of conductors allowed in a conduit, follow these steps. Firstly, identify the type and size of the conductors you will be using. Secondly, determine the type and size of the conduit you will be using. Thirdly, consult the NEC tables to find the dimensions and cross-sectional areas of the conductors and conduit. Fourthly, calculate the total cross-sectional area of the conductors. Fifthly, compare the total cross-sectional area of the conductors to the allowable fill percentage of the conduit. Sixthly, ensure that the installation complies with all applicable codes and regulations. Proper conduit fill is essential for safe and efficient electrical installations. Overfilling a conduit can lead to overheating, insulation damage, and electrical hazards. By following the NEC guidelines and accurately calculating conduit fill, you can ensure that your electrical installations are safe and compliant. Always refer to the latest edition of the NEC and consult with a qualified electrical inspector or engineer if you have any questions or concerns. The NEC provides specific tables for calculating conduit fill depending on the type of conduit and the type of wire being used. These tables are based on the cross-sectional area of the wires and the internal area of the conduit. The tables will specify the maximum number of wires of a certain size that can be placed in a particular size of conduit. It is important to consult these tables to ensure that the conduit is not overfilled. Overfilling a conduit can cause the wires to overheat, which can lead to a fire. The NEC also requires that all electrical work be performed by a qualified electrician. A qualified electrician will be familiar with the NEC and will be able to ensure that the electrical work is performed safely and in accordance with the code. In addition to the NEC, many local jurisdictions have their own electrical codes. These local codes may be more restrictive than the NEC. It is important to be familiar with the local electrical codes before performing any electrical work. When installing wires in a conduit, it is important to use the proper tools and techniques. The wires should be pulled through the conduit using a wire puller. The wire puller will help to prevent damage to the wires. The wires should also be lubricated with a wire pulling lubricant. The lubricant will help to reduce friction and make it easier to pull the wires through the conduit. Once the wires have been pulled through the conduit, they should be terminated properly. The terminations should be made in accordance with the manufacturer's instructions. Improper terminations can lead to loose connections, which can cause a fire. The NEC provides specific requirements for the installation of electrical equipment. These requirements are designed to ensure that the electrical equipment is installed safely and in accordance with the code. It is important to be familiar with these requirements before installing any electrical equipment. The NEC is a complex document, and it can be difficult to understand all of the requirements. If you have any questions about the NEC, you should consult with a qualified electrician. A qualified electrician will be able to answer your questions and help you to ensure that your electrical work is performed safely and in accordance with the code. It is important to remember that electricity can be dangerous. If you are not familiar with electrical work, you should not attempt to perform it yourself. Always hire a qualified electrician to perform electrical work. A qualified electrician will have the training and experience necessary to perform the work safely and in accordance with the code. When working with electricity, it is important to take certain safety precautions. Firstly, always turn off the power to the circuit before working on it. Secondly, use insulated tools. Thirdly, wear safety glasses. Fourthly, never work on electrical equipment when you are wet or standing in water. Fifthly, if you are not sure how to do something, ask a qualified electrician for help. Electricity is a powerful force, and it can be dangerous if it is not handled properly. By following these safety precautions, you can help to prevent accidents. In summary, knowing the conduit fill requirements outlined in the NEC is crucial for safe and compliant electrical installations. For 3/4-inch EMT conduit, the maximum allowable number of number 10 AWG stranded wires is 3. Always consult the latest edition of the NEC and local codes, and seek guidance from qualified professionals when necessary.